Review number 3, circuit sudoku. Let's answer these without doing any calculations on a calculator. Let's just use our brains. Which of these resistors has the most current? There's our diagram right there, and that is definitely going to be the 4 ohm resistor. We can do this without a calculator, and we know that because all of the current that's flowing in this circuit has to go through this 4 ohm resistor. In each other case, the current splits. Part of it goes one way, part of it goes the other. Then it comes back together. Clearly, the current must be the greatest in this 4 ohm resistor. What fraction of the current that flows through the battery flows through each resistor? For the 4 ohm resistor, it's 100%, all of it. Whatever current is flowing through the battery, that's got to be the same that flows through this 4 ohm resistor. What about through the 3 and the 6 here? Well, let's see. The pressure difference across these is equal. It's an equal push across the 3 and across the 6 ohm resistor, but the 6 has twice as much resistance. So 2/3 of the current will be going the easy way, and 1/3 will be going the tougher way. And that is held true with this 9 and 18 ohm resistor as well. The 18 ohms has twice as much, so it's going to have half of the current that the 9 ohm resistor has. Now we have the same diagram, and we are asked to complete this circuit sudoku. So this is a 36 volt battery. I like to use color coding on the circuit. That helps me see visually what we're dealing with sometimes with regard to the voltage. So there's 0 volts of pressure. That portion of the circuit has 36 volts of pressure. This portion of the circuit will have some other electrical pressure, so many volts, we don't know how many at this point. And then this portion of the circuit will have a different voltage. And remember that the V's in the table are the difference across each of these. So that's why in the table it says 36 volts different from one side of the battery to the other. Let's figure out the resistance perceived by the battery. These two resistors, 9 and 18, are in parallel. And so if we use the 1 over rule, 1 over 9 plus 1 over 18, that's like 2/18 and 1/18, which is 3/18. Flip it upside down. So the resistance of this portion is 6. The resistance of this guy, you could figure it out, is 2. So 6 plus 4 plus 2, that's 12. So the current going through the battery is going to be 3 amps. The resistance felt by the battery is 12 ohms of resistance. And what was the equation for power? Power is I times V. So I times V is going to be 108 watts. That means there are going to be 3 amps going through the 4 ohm resistor. And we said earlier that between the 3 and the 6 down here, we said that 2/3 of the amps would go through the 3. 2/3 of 3 is 2. And 1/3 of the amps would go through the 6 ohm resistor. So that's 1 amp. Similarly, we said 2/3 of current would go through the 9 ohm resistor, and 1/3 would be going through the 18 ohm resistor, like that. All right, so let's see what this gives us. 3 times 2 is 6 volts. 4 times 3 is 12 volts. 6 times 1, that's going to be 18 volts, and that's going to be 18 volts. All right, let's see if this makes sense. Actually, it does. Look at across the 9 and the 18 ohm resistors, the voltage drop is the same. It's 18 volts different from one side to the other. Therefore, we can conclusively say now that the electrical pressure of that region would be categorized by 18 volts. Across the 4 ohm resistor, the pressure drops by another 12. And so here it's 18. If it drops by 12, this must be 6. And so look at that. That agrees with what's in our table right there. 6 volts and 6 volts both across there. All right, let's calculate the powers real quickly. V times I, so that's going to be 12 watts. That's going to be 36 watts, 6 watts, 36 watts, and 18 watts. And what does that come out to? 72, 90, 100, 108. Look at that. You add all those up, that comes out to 108. The power delivered by the battery is equal to the power consumed by the resistors. All right. For energy to be conserved, what must be true with regard to the values that make up the rightmost column? The power output by the battery should equal the sum of the powers consumed by the resistors, which it is. And we already did this, so we're going to end it here. Show the calculation that verifies or demonstrates the validity of that answer. We just did. All that stuff I circled adds up to 108. That's what's consumed by the resistors, and there's the power delivered by the battery.